Here we have the infinite series 2 dividing by 4n squared minus 1, and we want to show that this infinite series converges to 1. And so first, 4 minus 4n squared minus 1, we need to factor the bottom here. So 4n squared minus 1 is the same as 2n plus 1 times 2n minus 1. And then we need to decompose this fraction right here. And so 2 divided by 2n plus 1 times 2n minus 1 is the same as constant a dividing by the factor 2n plus 1 plus constant b dividing by 2n minus 1. This is a fraction plus a fraction, so we can cross multiply a times 2n minus 1 plus b times 2n plus 1, and then dividing by the product of the two denominators. And so here we have the denominator on the left side is the same as the denominator on the right side, and therefore the numerators, the two numerators, have to be the same. And now we need to figure out what's a and what's b, and this equation is true for all n. And so first, look at the factor next to the constant a. Find something that we can put in the place of n that will make this factor 0, and that will give us b. And so we let n be 1/2. 2 times 1/2 is 1. 1 minus 1 is 0. So if we let n be 1/2, then in the place of n we have 1/2, 1/2. 2 times 1/2 is 1. 1 minus 1 is 0, so we get 0a. 2 times 1/2 is 1. 1 plus 1 is 2, so we get 2b. And then divide both sides by 2, we get b to be 1. And so that's how we figure what b is trying to figure out something that we can put in the place of the, that would make the factor next to the constant a 0. And then now to figure out what 8 is, we do the same thing. What can we put in the place of this n that would make this part right here 0? So here we can let n be negative 1/2, because 2 times negative 1/2 is negative 1. Negative 1 plus 1 is 0. So we let n be negative 1/2, then n we have 1/2, negative 1/2, n here we get negative 1/2. 2 times negative 1/2 is negative 1. Negative 1 plus 1 is 0, so we get 0b. 2 times negative 1/2 is negative 1, minus 1 is negative 2, so we get negative 2a. And then dividing both sides by negative 2, we get a to be negative 1. And so a will be negative 1, b will be 1. And so now this is the original series right here. 2 over 4n squared minus 1 is the same as negative 1 over 2n plus 1 plus 1 over 2n minus 1. And the sum of the first 10 terms, so when n is 1, we get 3 here and we get 1 here. When n is 2, we get 5 here and we get 3 here. When n is 10, we get 21 here and 19 here. So the sum of the first 10 terms is 0.9523. The sum of the first 100 terms is 0.995. The sum of the first 1,000 terms is 0.9995. the sum of the first 10,000 terms is 0.99995. And the sum of the first 10,000 terms will be 0.999995. And it looks like from this pattern, as n gets larger and larger and larger, the sequence of partial sums, these are called partial sums. These are here, they call partial sums. So the sequence of partial sums is approaching 1. So that's what it looks like. In other words, the limit of s of k as k approaches infinity is 1 by just looking at this pattern right here. And now let's go find the sum of the first k terms, or s of k, and then we can show that this limit of s of k is equal to 1. So we have just found that this sum right here, this infinite series, is the same as the series of negative 1 divided by 2n plus 1 plus 1 divided by 2n minus 1. So here's the first term, the second term, the third, the fourth, the fifth, and this is the kth term. And then this is the k minus 1 term. And so the kth term in the place of n, we just put k. And the k minus 1 term in the place of n, we put k minus 1. And then simplify a little bit. This is 2k minus 2 plus 1, which becomes 2k minus 1. And this will be 2k minus 2 minus 1, which will become 2k minus 3. But if we look at the pattern right here, we will see that this negative 1/3 and 1/3 here, that will be 0. This negative 1/5 and plus 1/5 will be 0. Negative 1/7 and 1/7 will be 0. And so in fact, all of these will be 0. And then we can see right here, this is 2k minus 2 plus 1, which is 2k minus 1. And they will cancel out with this one. And then eventually this one will also get canceled out. And so the only thing that's left is the 1 over 1 and negative 1 over 2k plus 1. So the sum of the first k terms will be 1 plus negative 1 over 2k plus 1. And so we have just seen that the sum of the first k terms is just 1 and then plus the negative 1 over 2k plus 1. This is the infinite series, which is the same as the limit of s of k as k approaches infinity. But s of k is 1 plus negative 1 over 2k plus 1. As k approaches infinity, this right here will go to 0, because negative 1 divided by infinity will be 0. And so we end up with 1. And therefore, this, we have just shown that this infinite series, the infinite series 2 divided by 4n squared minus 1, converges to 1.